chapter 7, problem number 1, we see that a couple of questions. Is YTM on a bond the same as the required return? And the answer is yes. YTM, percent YTM, or percent R is the same as the rate required by all other bonds in the market. Is the YTM the same as the coupon rate? The answer to that one is no. YTM is rate required by all other bonds in the market, whereas coupon rate is the rate on your bond that you're holding in your hand. Suppose a 10% coupon bond sells today at par value, typically $1,000. 2 years from now, the required return on the same bond is 8%. And what is the coupon rate now? What is the YTM? The equation is coupon rate is coupon over face value. So you can always determine the coupon rate. It's dollars divided by dollars. Dollars of coupon divided by dollars of face value. So we get a percent answer. The solution on this one, the coupon rate is still 10%. That never changes. So as long as you're holding that bond and you don't sell it, you always get paid that $100 on a $1,000 face value bond. And the YTM is now 8%. Required returns of all other bonds in the market will go up and down over the course of the life of your bond as you hold your bond. In this case, it had gone down to 8%. So all the bonds in the market are paying 8%. Your bond's still paying 10%. There are your answers to problem number 1. In problem number 2, we have a 7% coupon 20-year bond purchased today at par value. 2 years from now, your interest rates go up to 15%. So the coupon in dollars on your bond is $70 or 7%. And now all of the bonds in the market are paying $150 or 15%. What happens to the value of your bond and why? The equation is price of the bond is equal to the present value of the coupons plus the present value of the face, or C times 1 minus 1 over 1 plus R to the T, all of that over R, plus face value over 1 plus R to the T. So there's your equation. And we see in this one that your percent R is going up. So we're dividing all these figures by a larger number. So when we do that, the bond value goes down as the required return goes up. So when interest rates go up, bond values go down. When interest rates go down, bond values go up. There's your answer to problem number 2. In problem 7.3, we have a German company that has 6.4% coupon bond on the market. 25 years time to maturity. If the yield to maturity is 7.5%, what is the bond price in euros? So this one we're going to give in euros. Same equation, price of the bond is C times 1 minus 1 over 1 plus R to the T, all of that over R, plus FV over 1 plus R to the T. Present value of the coupons plus present value of the face. Price of the bond then is, I'm going to plug in 64 for C, which is 6.4% of 1,000. I'm going to plug in 0.075 for R, and I'm going to plug in 25 for T and 1,000 for FV. When I do the math, I get an answer. The price of the bond is 877.38 euros. That's the answer to problem number 3. In problem number 4, we have a Japanese company that has 4.3% coupon bonds with 18 years time to maturity. The bond sells for 87,000 yen. What is their YTM? Same equation, price of the bonds equal to the present value of the coupons plus present value of the face. So for the price of the bond, I'm going to put in 87,000 yen. For the C, I'm going to take 4.3% of 100,000 yen. The par value of the bond would be 100,000 yen. So I'll take 4.3%, which is the coupon rate, times 100,000. That gives us 4,300 to plug in for C. R is what we're looking for. T is 18. And FV will be 100,000, and again, T is 18. And if I solve this equation for percent R or YTM, I get 5.451685%. There's your answer to problem number 4. In problem number 5, Page Enterprises has bonds with 9 years time to maturity, selling for $948, so it's a discount bond. The YTM is 5.9%. What is the coupon rate? C divided by $1,000. So in this problem, we're going to use the same equation. We're going to solve for C this time, coupon, and then we're going to divide that coupon divided by $1,000 face or par value to get our coupon rate. So for price of the bond, we're going to plug in 948. For C, we're going to plug in C. That's what we're looking for. For R, we're going to plug in 0.059 in both places. For T, we're going to plug in 9 years. and FV is 1,000, R is 0.059, and T is 9. If I solve this equation for C, or coupon, I get a coupon of $51 and about 39 cents. I divide that by 1,000 and I get a coupon rate of 5.1388%. And that's your answer to problem number 5. In problem number 6, Ninja Company has 14-year bonds issued 1 year ago, meaning they have 13 years left to go at a coupon rate of 6.9%. Semi-annual payments, so we must go C by 2, R by 2, and T times 2 in this one. The YTM is 5.2%. What is their bond price? The price of the bond is present value of the coupons plus present value of the face. And again, I must do coupon by 2, yield to maturity by 2, and T times 2, because I'll actually be going in and collecting my coupon twice a year at half of the coupon amount. So price of the bond is equal to C. What do I plug in for C? Well, I take the 6.9% or $69. 6.9% of 1,000 gives me $69, but I'm going to have to go in to the paying agent twice to get that. So I'm going to get $34.50 each time I go in. C by 2. So 69 divided by 2, $34.50 is what I plug in for C. What do I plug in for R? Well, the yield to maturity, or percent R, is 5.2%. I divide that by 2, C by 2, R by 2, so 5.2% divided by 2 is 2.6%. I put 0.026 in for R. And then for T, it is 13 years left on my bond, but I have to go in twice a year to collect my coupon payment. So T times 2. So 13 times 2 is 26. I plug in 26 for T in all cases, and I come up with an answer of price of the bond equals $1,159.19. 1159.19. There's your answer to problem number 6. In problem number 7, we have Stone Sour Corporation issuing 20-year bonds 2 years ago. Means there are 18 years left on this bond. Coupon rate is 7.1%. They provide semi-annual payments, meaning you have to go into the paying agent twice per year. Bond sells for 105% of par. What is the YTM, or percent R? So we're solving for little r in this case. Same formula as always. Price of the bond is equal to the present value of the coupons plus present value of the face. And again, I must do C by 2, R by 2, and T times 2 because we have semi-annual payments. So for the price of the bond, I'm going to put in 105% of par, or 105% of 1,000. That's $10.50. For C, I'm going to plug in the coupon rate of 7.1% times 1,000, which is $71, but I have to divide that by 2, C by 2. So I'm going to plug in $35.50. I'm going to collect that twice a year, totaling $71 for the full value of the coupon payment. R, I'm going to plug in R because that's the variable I'm looking for. And for T, I'm going to plug in T times 2. It's a 20-year bond issued 2 years ago, meaning there are 18 years remaining. 18 times 2 is 36. I'll get 36 payments on this bond, so I'm going to plug in 36. And for FV, I'm going to plug in 1,000. Solving for little r for this one, I get 6.6205%. 6.6205%, your answer to problem number 7. In problem number 8, we have Ponzi Corp with a bond with 14.5 years time to maturity, a yield to maturity of 6.1%, a price of $1,038, so therefore it's a premium bond. Semi-annual payments again, C by 2, R by 2, T times 2. And what is the coupon rate? C. Again, same formula we're going to use that we've used in the past several problems. And again, we're going to have to remember to go C by 2, R by 2, T times 2 on this problem. So the price of the bond is simply $10.38. That's easy to figure out. C is what I'm looking for, so I'm going to plug in C as the unknown variable. What do I plug in for R? Well, let's see, 6.1%, again, divided by 2. C by 2, R by 2, T times 2. So I have to take that required return by 2. 6.1 divided by 2 is 3.05%. That's what I'm going to plug in for R. Time to maturity of 14.5 years, but we have to multiply by 2, so 14.5 times 2 is 29. And again, 0.0305 goes in for all the R's and 1,000 for the face value, and I get a coupon rate of 6.4985%. Now when you get the original answer coming out of that formula, you're going to get approximately 3.25%. We must remember that we have to multiply that by 2 because that's only half of the coupon. So the coupon rate, so 3.25% times 2, and that gets me up to approximately 6.5% for the annual coupon rate. There's your answer to problem number 8. On problem number 9, we're going to solve for the Fisher effect. T-bills are paying 6% nominal, which means total, and inflation, letter H, is 2.6%. What is the real rate of interest, little r? So we're looking for little r in this exact Fisher equation. So for big R, nominal rate, I plug in 6%. For little r, I plug in r. That's the variable I'm trying to solve for. And for h, I plug in 2.6%. So 1.06 equals 1 plus r times 1.026. So approximately, to get the approximate Fisher effect, to get around the answer before I even solve for the exact, I can just take 6 minus 2.6. So my approximate rate should be around 3.4% when it's all said and done. When I plug the numbers into the exact Fisher effect equation, I get 1 plus 0.06 equals 1 plus r times 1.026. The exact percent r is 3.3138%, so my approximation of 3.4 is not too bad. I'll take it. Exact Fisher effect, 3.3138 is your answer to problem number 9. In problem number 10, we have the real rate on a T-bill is 2.5%, inflation is 4.1%. What is the total or nominal return on this T-bill is the question. So in this case, obviously we're looking for big R. Equation is 1 plus big R equals 1 plus little r times 1 plus h. Approximately, I can get by approximating this answer by taking little r plus little h. So my exact equation is 1 plus big R equals 1 plus 0.025 for R times 1 plus 0.041 for h. But I want to approximate it first. I know that I can approximate it by taking r plus h, so 0.025 plus 0.041 gives me an approximate answer of 6.6%, so I know my final answer should be somewhere in that ballpark. I plug in the exact numbers, 1.025 times 1.041 minus 1. I get an exact answer of 6.7025%. Again, my approximation is very close, not bad, I'll take it. There are your answers to problem number 10. In problem number 11, Fred Bernanke says that the real rate will be 7%. That's your little r. An investment offers a total nominal return of 13%. What is inflation at this time? So in this case, we're looking for little h. Same equation, the Fisher effect, 1 plus big R equals 1 plus little r times 1 plus h is the exact Fisher effect. Approximately, we can say that big R is equal to approximately little r plus little h. So for the exact equation, I put in 1 plus 0.13 equals 1.07 times 1 plus h. And before I do that, I always do the approximation. What's my answer going to roll out approximately? So approximately, it should be 0.13 minus 0.07, or about 6%. That's what I should get for an answer. And when I put in the exact figures, 1.13 equals 1.07 times 1 plus h. Solve for h, I get an exact h of 5.6075%. Again, my approximation is very close. Not bad, I'll take it. There's your answer to problem number 11. In problem number 12, your total return is 10.7%. Inflation is 3.7%. What's the real return? Again, I'm looking for little r. Using the same Fisher effect equation, 1 plus big R equals 1 plus little r times 1 plus h. I plug in 1.107 for 1 plus r. Looking for little r, and then 1.037 for 1 plus inflation. But again, I want to check my answer approximately in my head before I get the exact answer, so I can take simply the 10.7 minus the 3.7. I should get an answer around 7% when it's all said and done. So I divide 1.107 divided by 1.037, bringing this to the other side, and then I subtract 1. isolate R, I get an exact answer of 6.7502, which is very close to my approximation of 7%. Not bad, I'll take it. There's your answer to problem number 12.